The next new chapter is classification of element and periodicity in properties. Already the classifications of elements you were studied in the class 10. Already you are aware of that triad system, Newland, Octaves, Newland's Octaves, musical notes. Then the triad means there is a Daubernier, Newland, Octaves, and the Mendeleev periodic table, like this. See, in that modern, we are going to discuss here the modern periodic table, that is modern periodic law and the present form of the periodic table. The present form of the periodic table that is acceptable for the long term, long form of the periodic table, S block, D block, P block, and that F block. We will discuss this modern periodic table. See, the modern periodic law. See, the modern periodic law is there is Mendel is developed his the periodic table. Chemists knew nothing about the internal structure of the atom. However, beginning of the 20th century, they profound the developments in the theories of subatomic particles, the subatomic electron, neutron, proton. This and here that observed, one English physicist observed regularities of the characteristics of the X-ray spectra. See the X-ray spectra of the element that plot as root V. Here the root V, V is the frequency X-ray emitted. So against atomic number, the atomic number is Z. So gave a straight line and not the plot of root V. That is root V versus atomic mass. The atomic number is more fundamental property of the element than its atomic mass. So the Mendeleev periodic law was accordingly modified. So this is called Mendeleev modern periodic law. Okay. The statement is the physical and the chemical properties, of the element elements are periodic function of their atomic numbers. The physical and the chemical properties of the elements are periodic function of their atomic number. Is called modern periodic law. Here the periodic law revealed important analogies among the 94 elements are naturally occurring. And the remaining is synthesized. That is, it is stimulated to renewed interest in inorganic chemistry and has carried into the present with the creation of the artificial, that is man-made, produced short-lived elements. So the remainings are the short-lived elements. You may recall that the atomic number is equal to the nuclear charge. The nuclear charge is marked, there is number of protons or the number of electrons in neutral atom. So that is easy to visualize the significance of the quantum numbers and the electronic configuration in the periodicity of the element. So in fact, it is now recognized that the periodic law is essentially the consequence of the periodic variation in electronic configuration, which indeed determine the physical and the chemical properties of the compound. So the modern version of the periodic table, that is the periodic element, the long form periodic table. Long form periodic table, that is the most convenient and widely used, that is the horizontal row. Horizontal rows which Mendeleev called series. Then the vertical columns are groups. This is Mendeleev called series. In horizontal rows, we can call that is modern periodic table, that is periods and the groups. So elements having the similar outer electronic configuration in their atoms are arranged in the vertical columns, that is referred to as a groups or families. See, according to the recommendation of the IUPAC, that is International Union of Pure and Applied Chemistry, the groups are numbered from 1 to 18. That is replacing the older notation, that is group A. Older notation is 1A, 2A, 1B, 2B, like this. So that is replaced in the group 1 to group 18. So they are all together 7 periods. So they have a 7 periods. And 18 groups. The period numbers corresponding to the highest principal quantum number, the principal quantum number, that is n, of the element in the period. The first period of the contains 2 elements. That is subsequent. The period consists of 8, 8, 18, 18 and 32. These are the elements having respective that is the consist of the electron, that is elements. Like the 7th period in this incomplete, and like the 6th period would have to theoretical maximum, that is on the basis of their quantum number of the element, that is 32 elements. In this form of the periodic table, there is 14 elements of both 6th and 7th periods, that is F block. Simply we can tell that F block. Lanthanoids and actinoids are placed in the separate panels of the bottom. Then the nomenclatures of the elements with more than 100. Atomic number is 100 and above. Nomenclature of elements with atomic number greater than 100. That is 100 and 100, 101, 102, up to 118 elements. The naming of the new elements had been traditionally the privilege of the discoverer, and the suggested name was the ratified by the IUPAC system, this International Pure Union of Pure and Applied Chemistry. In recent years, this has led to some controversy. The new elements with very high atomic numbers are that's mean are unstable, that is only minute of quantities. Sometimes only a few atoms of the them are obtained. So here a systematic nomenclature, so that a systematic nomenclature be derived directly from the atomic number of the element using the numerical roots for 0 and the numbers 1 to 9. So these roots are put together in order to digit which make up the atomic number, and that is end with IUM, that is added to the at the end. The IUPAC name of the elements, I will give the digit, that is notation of the IUPAC nomenclature of element. First notation for IUPAC nomenclature of element. So digit 0, the name will be that abbreviations. So digit 0 means the name will be nil. Abbreviation simply n. Digit 1 UN, and the abbreviation is U. 2 by, and the abbreviation is B. 3 tri, the abbreviation is T. 4 quad, and the symbol is Q. 5 pent. The symbol is P. 6 hex, symbol is H. 7 sept, the symbol is S. 8 oct, the symbol is O. 9 N ENN, and the symbol is E. See, this is the notation for IUPAC nomenclature of the element. Then the nomenclature of the element with the atomic number above 100. Here the nomenclature of element with the atomic number above 100, the atomic number, the name according to the IUPAC nomenclature, symbol, IUPAC official name, and IUPAC symbol. So we will see all that 101 to 118 elements list wise here. The atomic number 101, the nomenclatures of the that is according to the IUPAC nomenclature, the name is unyl unium. That is the symbol is UNU. Then the official name of IUPAC name is Mendelevium. Then the symbol is MD. Then the atomic number 102, Unilbium, the symbol is UNB. The IUPAC official name is Nobelium, and the symbol is NO. Here the first letter is capital, second letter is small on all elements. Then 103, atomic number 103, Unil Trium, the symbol is UNT. The name of the IUPAC name of the element is Lawrencium, the symbol is LR. The 104 element, atomic number 104 is Unil Quadrium, symbol is UNQ, and the IUPAC official name is Rutherfordium, the symbol is RF. Then atomic number 105, the nomenclatures of the IUPAC is Unil Pentium, UNP, and IUPAC name is Dubnium, the symbol is DB. The 106 atomic number is Unil Hexium, symbol is UNH. Then the IUPAC official name is Seaborgium, the symbol is SG. And the atomic number 107, Unil Septium, the symbol is UNS. The official IUPAC name is Bohrium, the symbol is BH. Atomic number 108, Unil Octium, the symbol is UNO. Name of the IUPAC of the element is, IUPAC name of the element is Hassium, symbol is HS. Then the atomic number 109, the name of the IUPAC name of the nomenclature is Unil Enium, symbol is UNE, and the name of the compound is, element is Meitnerium, the symbol is MT. And 110, atomic number 110 is Unanilinium, the symbol is UUN. Then the IUPAC name is Dramstadium, the symbol is DS. Then atomic number 1111, the nomenclature name is Unnium, UUU, symbol is this, and the IUPAC name is Rontgenium, the symbol is RG. 1112 atomic number, the IUPAC nomenclature is Ununbium, symbol is UUB, and the name is Copernicium, symbol is CN. And here the atomic number 113, 115, 117 and 118 there is no official IUPAC name is announced, and the symbol also not announced yet. So here the atomic number, the 1113 is unknown trium, that nomenclature according to the IUPAC name according to the IUPAC nomenclature is unknown trium. The symbol is UUT. And 1114 unknown quadium, the symbol is UUQ, and the IUPAC name is fluorovium. Fluorovium FL, the symbol is FL. Then atomic number 115 unknown pendium, the symbol is UUP. The IUPAC name is not yet announced. That atomic number 116 unknown hexium, the symbol is UUH, and livermorium, that is symbol is LV. Atomic number 117 unknown septium, UUS. IUPAC name is not yet to be announced. 118 atomic number unknown octium, UUO. IUPAC name and symbol is not yet to be announced. So these are the nomenclatures of the elements with the atomic number more than 100, that is above 100. That means 101 to 118 elements. So these are the list. You can see that UNU, that is for 1, UNB simply by means UN with by B, try UN with T, UN quad, so 4 means Q, 5 pent, so that UNP, hex UNH, heptium, so that septium UNS, octium UNO, enium 9 for 9 UNE, 10 just simply UNN, nillium, then ananium, so that you have to use UUUU, then ananbium simply again UB, UUT, UUQ, UUP, UUH, UUS and UUO. So these are the nomenclatures of elements with the atomic number above 100. The new elements first gets a temporary name, that is with symbol consisting of the 3 letters. So this is the temporary name. The permanent name and the symbol are given, that is the IUPAC name. This is the permanent name and the symbol. So that symbols are given by vote of the IUPAC representatives from each country. So then the permanent name might reflect the country, that is in which the element was discovered, or pay tribute to the notable scientist. So as of now, elements with atomic numbers up to 118 have been discovered. So here the elements number 113, 115, 117 and 118 are not yet to be announced by IUPAC system. Thank you.